video for AQA Mechanics. This is Dimension Analysis Section 1.4. We're looking at modelling using dimension analysis. In the last few videos we've introduced the idea of the dimensions of quantities, mass, length and time. And I want to consider how we can use these when we're faced with the idea of trying to model some experimental data perhaps that we've got and trying to decide on what formula might fit a particular situation. First of all, based on our knowledge of the situation, we try to come up with a formula which is a product of the quantities and powers of those quantities that we think might affect the situation. We call these powers alpha, beta, gamma, etc. And then we probably would then include a dimensionless constant, usually something k perhaps. And once we've done that, we use indices to compare the mass, length and time on both sides of the equation to come up with a deduction for the values of alpha, beta and gamma. So as an example of this in practice, I'm going to consider the following situation, which is a pendulum. So if we have a mass on the end of a string, then we're going to say, well, what quantities might affect the period of oscillation of the pendulum itself? Well, if we consider the things that might affect the period of the pendulum, and the things that we can alter, we can certainly alter the length of the string. We could alter the mass of the bob, m. We could alter the angle that we release the bob at, which I'm going to call theta 0 with a subscript 0. And really that's about it, other than perhaps one that you haven't thought about, which is g, the acceleration due to gravity. Now, in a particular place that's going to be a constant, but what if we move to a different position on the Earth's surface maybe, or even took our pendulum to the moon, where the acceleration due to gravity is going to be different? So we have the string length L, the mass m, the acceleration due to gravity g, and the angle release theta 0. So if we put those together in a formula, then we're going to get that the period that we expect for our pendulum is going to be equal to k, the dimensionless constant, L to the power alpha, m to the power beta, and g, acceleration due to gravity, to the power gamma. Putting that in terms of the dimensions of the quantities, then on the left hand side the period is a time, so we've got t. K is dimensionless, so it doesn't have any dimensions at all. Length L, obviously a length, so we've got L to the power alpha. The mass m is m, so m to the power beta. And the acceleration due to gravity, acceleration, is length t to the minus 2, lt to the minus 2. And that will all be raised to the power gamma. So now we need to compare the dimensions on each side of our equation. So comparing the powers then on each side of the equation, m on the left hand side is 0, on the right hand side beta, so beta must be 0. For t we've got 1 on the left hand side, 1 on the right hand side, minus 2 gamma, and therefore gamma must be equal to negative 1/2. And finally L, 0, is equal to alpha plus gamma. So if gamma is negative a half, that means that alpha must be equal to 1/2. So now we can transfer those values of beta equal to 0, gamma equal to negative a half, and alpha equal to a half to our formula to give us the fact that the period must be equal to k, the constant, the length to the power a half, mass to the power 0, and g to the power negative a half. More usually that's written as the period is equal to a constant k and then the square root of L over g. Now in actual fact we find that the period is approximately equal to 2 pi root L over g. So approximation, it's only true for small angles of release. So where we had theta 0, if we had large angles, then we would have to change this idea of the period being equal to just related to root L over g. So it's important to show that, rather, or to note that we haven't actually proved anything by this method. We've just come up with a formula which we think is going to be one which is certainly relevant and may fit the situation. However, we could then check whether our formula seems to be correct by doing more experiments. So this idea then of thinking about the quantities that may be involved in any particular situation, and then using the powers and using dimension analysis to try and determine those powers, is our idea of dimension analysis being used in modelling. This brings this video to an end, and indeed is the final one in the series on dimensional analysis.